Okay, so this is the end of chapter 9, 9.7, law of sines and law of cosines. Don't break the law, breaking the law, breaking the law. Essential question, what are the law of sines and the law of cosines? What you will learn in this chapter section is how to find the areas of triangles, use the law of sines to solve triangles, and use the law of cosines to solve triangles. So let's take a look. Okay, so example 1 says finding trigonometric ratios for obtuse angles. So the difference here is we're now dealing with obtuse angles. So in other words, we don't have a 90-degree triangle anymore because you can't have an obtuse angle in a 90-degree triangle or in a right triangle. Use a calculator to find each trigonometric ratio. Round your answer to 4 decimal places. Okay, it's just basic practicing of key punching. So you write the tan of 150 degrees is approximately, because we are going to round. Now remember, turn your calculator on, always go to mode and make sure you're in degrees. I'm going to remind that over and over and over. Go to degrees and hit enter. And now go to your home screen and do what you want to do. So tangent of 150 is negative 0.5773. Or we're going to round to 4 decimal places, and the fifth one's a 5, so that's going to become a 4. So it's negative 0.5774. Okay, so the tangent's negative. I'm going to explain that really quickly, just 1 second here. Okay, I changed my mind on what I was going to show you there, so I'm just going to continue and pretend you didn't see that. Okay, now sine. The sine of 120 degrees, so what you write is the sine of 120 degrees is approximately, go to your calculator, sine 120, close parentheses, enter. It's approximately 0.8660. The 2 in the 5th position rounds down, and then finally cosine 95. So then cosine of 95 degrees is approximately, and I hit the cosine button, 95, close parentheses, enter, and I get negative 0.08715 makes that a 2. So it's 0.0872, and that's it. That's all you do. Make sure you're in degree mode and use your calculator to get these approximations to 4 decimal places. Now try numbers 4, 6, and 8 in your exercises. Okay, core concept, area of a triangle. Now we're familiar with area is 1/2 base times height, but in this triangle, they're saying that the area of any triangle is given by 1/2 the product of the lengths of the 2 sides times the sine of their included angle. Okay, so let me explain that. So if I go to my highlighter here, and let's just use green, and I'll make it thinner like this. So BC sine A. So this is side B right here, which is between A and C. So that's B. And C is right here. So it's the 2 sides that form the angle. So you take 1/2 this side times the sine of that angle. And so it works the same. If you're looking for B, then it'd be 1/2 A times C sine B. For angle C, we would do 1/2 A times B times the sine of C. So it's the included angle and the 2 sides that form that angle, and you take half of it. Sine of the included angle times the 2 sides divided by 2. So that's the area of a triangle formula. So let's take a look at it in an example. Okay, so here's example 2. It says to find the area of the triangle, round your answer to the nearest tenth. So this is not a right triangle. So if it's a right triangle, it's just leg times leg divided by 2, but this is different. We have an obtuse angle, And we don't know the height, which would be over here, like so. So how we do this is the angle we know. So this is our reference angle right here. The two sides that are formed by this are this side here, AC, and the other one, let's use purple, is this side over here, which is AB. So that sets up our equation. So the angle we know is this, what we're going to take the sine of. So the area of the triangle equals, so you just say area equals 1/2 one side. And remember, if this is angle B here, this is side B. And if this is angle C, the side opposite is side C. So area equals 1/2 B times C times the sine of angle A. So there's our formula. Substitute the givens. B is 19. C is 17. And then we do the sine of 135 degrees. Actually, I don't need a parentheses there. The sine of 135 degrees. Okay, so I could do this manually until I get to here without a trig table, but I'm just going to do it all on my calculator. So let's just zoom this over like so. Turn my calculator on, check, see that it's still in degrees, second, quit, clear, and here we go. 1/2. 1 divide 2 in its own parentheses, then the parentheses 19. Oops. Parentheses 19, close the parentheses 17, close the parentheses. So we have the 1/2, we have the 19, we have the 17. We take the sine of 135, close the parentheses, hit enter, and we get the area, and it's approximation because of that sine function. 114 point, round answer to nearest tenth. Always go back and read the directions. 0.19 becomes 0.2. So the area of this triangle is 114.2, and they didn't say inches, feet, or whatever, so I just say units squared. And there you have it. So try this on exercises 9 and 10. Okay, using the law of sines, the trigonometric ratios in the previous sections can only be used to solve right triangles. You will learn two laws that can be used to solve any triangle now. You can use the law of sines to solve triangles when two angles and the length of any side are known. So AAS or ASA, two angles, a non-included side or an included side. Or when the lengths of the two sides and an angle opposite one of those two sides are known. In other words, SSA case. Okay, the donkey. All right, so theorem 9.9, law of sines says the law of sines can be written in either of the following forms for triangle ABC with sides of lengths A, B, and C. So side A is opposite angle A, side lowercase b is opposite angle B, and side C is opposite angle C. So we can set up a proportion of the sine of an angle divided by its opposite side equaling the sine of every other angle in that triangle divided by its opposite side. You can either put the sine in the numerator and the side in the denominator, or you could put the side in the numerator and the angle in the denominator. So, but you can't switch them. You can't say A over sine A equals sine B over B. You cannot flip-flop any. If you're going to put the sides on the top, put the angles on the bottom for all of them, or vice versa. So let's take a look at that in an example. Okay, so example 3 says using the law of sines, SSA case. So we have two sides and a non-included angle, SSA, and it says solve the triangle, round your decimal answers to the nearest tenth. Okay, so what do we look at the diagram they gave us? We know angle A, we know side A, and that's what's going to be key to answering this. When you know a side and or an angle and its opposite side, there's the ratio that's going to help you find everything else. So I'm going to say, oh, let me see. The book put the angle in the numerator for this example, so I'll do it backwards. So I'm going to say the side A is to the sine of angle A, and that's going to equal side B, which we know is over the sine of B. Okay, so we're trying to find angle B here. And I'm going to substitute my givens. A is 20. Sine of 115 equals side B, which is 11, over sine B. So I'm going to cross multiply, and I'm going to get 20 times the sine of B equals 20 times this equals 11 times this. 11 sine 115. Okay. So to get sine B by itself, we're going to divide by 20. Divide both sides by 20. These cancel, and we are going to get the sine of B equals, and we'll put this in our calculator. So calculator here, swing this over here, turn it on, make sure I'm in degrees. And here we go. Start with a fresh screen. I want 11 sine 115, 11 sine 115. Now, if I'm going to do this all in one step, you need to put all of this in parentheses, but to avoid confusion, just do the numerator first and hit enter, and you get a decimal, and then you divide that by your denominator, which is 20. And that way you don't have to deal with multiple parentheses and confusion. So the sine of B is 0.4985, is approximately 0.4985. Okay, so if you remember from the last chapter section, to find the angle now, we move the sine over to the other side. So now we say that B is approximately the sine of 0.4985. And so sine inverse, sine moved over to the other side. So now B is approximately the sine inverse of this decimal. So B is approximately second sine, and I'm going to do second answer here, and that will put that in without rounding. It'll be more accurate, and I get 29.89898, and it says round to the nearest tenth, so it's 29.9 degrees. Okay, so we found B. It's 29.9 degrees. Now I'm going to find C. So the measure of angle C plus the measure of angle A plus the measure of angle B equals 180 degrees. That's a triangle sum theorem. We are trying to find the measure of angle C. The measure of A is 115 degrees, and the measure of angle B is approximately 29.9 degrees, and that has to equal 180 degrees. Combine your like terms, and you get the measure of angle C equals 9. 9 and 5 is 14. Carry the 1. 2 and 1 is 3. Plus another one is 4. And 144.9 degrees. Oops, not equals. I'm not done. It's plus. That equals 180. Okay, so you combine like terms. Measure of angle C plus the sum of these two equals 180. Now subtract 144.9 degrees from both sides. And I'm going to put a 0.0 here. And let's move this degree out of the way. And put it right here. Okay, and we are subtracting both sides. This cancels, and I get the measure of angle C equals 8 to 7, 10 to 9, 10, 1.53. So it's 35.1 degrees. Okay, so we know angle A now, we know angle B, and we know angle C. Now all we have to do is find side C. So always use what you knew originally, that you don't have to round. So I know angle A. So now I'm going to do the reverse of what the book showed. They showed the side over the angle. What they're getting at there is, I'm just trying to show you that it works both ways. But when you're looking for an angle, put what you're looking for in the numerator, and in this case we're looking for a side, so you put that. But I'm going to do it backwards to show you that the answer comes out the same as in the book if you're following the book. So now I'm going to do, I know my A's and I'm trying to find my C's. So I'm going to do sine of A over A equals sine of C over C. Okay. And then I substitute my givens. So I say the sine of 115 degrees over 20 equals the sine of C, which is 35.1, over C. So the only thing we don't know here is C. So I cross multiply and I get C times the sine of 115 degrees equals 20 times the sine of 35.1 degrees. I'm trying to get C by itself, so I'm going to divide by sine of 115 degrees, divide by the sine of 115 degrees. So these will cancel, and I'll move it over here. C will be approximately, and we're going to put this in the calculator. So I go 20 sine 35.1, that's my numerator, hit enter. I got 11.5. Now divide that by a sine of 115. So then I hit divide, put a parenthesis here just in case. Sine 115, close the parentheses, enter. And I got 12.7, rounding to the 10th. 12.7. Okay, so C is 12.7. A was 11. I'm sorry, A was 20. B was 11. Now C is 12.7. The measure of angle C is 35.1, and the measure of angle B is 29.9. So just knowing one angle and two sides, I found the other two angles and the other side. Okay, so now try example or exercise 14. All right, example 4 is using the law of sines again, but in this case, it's the angle non-included side case. So it says solve the triangle, round decimal answers to the nearest 10th. Okay, so let's take a look at what we know. We know B, angle B, we know angle C, and we know side B. So ding, 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 we know B. Both things about B. So let's first try to find C. There's different steps we can take by doing this, by the way. So we can set it up as this. We can say A, the side A over sine of A equals B over sine of B. And when you know something, always put it in the middle. Okay, the one you know in the middle, because we're going to cross multiply in both cases and you'll see what happens here. And then C over sine of C to shining C. Okay, so here we go. We have two equations now, as you can see. I have one here. Where's my square? Rectangle. Let me make a rectangle. We have this ratio right here that I'm going to recopy. Let me do it in red. So I'm going to say A over the sine of A equals B over the sine of B. Okay, and then we also have this ratio set up. So I'm going to do that in green. So then we also have B over the sine of B equals C over the sine of side angle C. Let me make this C a little smaller. It looks like an angle, capital. It's lowercase c. Okay, so there we go. There's our two ratios given this one and this one, because we knew B, we knew the middle one. Okay, we know angle B, we know side B. Now we substitute our givens. So what is side A? We don't know. What is angle A? We don't know. Okay, so there's nothing I can do with that right now. But as you can see, we know two angles. So I can say the measure. So off on the side here, let's find A. So we'll do the triangle sum theorem first. The measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. The measure of angle A plus the measure of angle B, 25 degrees, plus the measure of angle C, which is 107, equals 180 degrees. Combine my like terms, so I get the measure of angle A plus 5 plus 7 is 12, carry the 1, 0 plus 1 is 1, plus 2 is 3, and then we have that 1 equals 180 degrees. Subtract 132 degrees from both sides, and we get A. These cancel, and I get the measure of angle A equals 8 to 7. 10 minus 2 is 8. 7 minus 3 is 4. 1 minus 1 is 0. So A is 48 degrees. Okay? Step 1, we found the angle A using the triangle sum theorem. Now we're going to substitute it in. We do not know side A, but now we're going to take the sine of angle A, which was 48 degrees, and that's going to equal side B, which is 15, over the sine of angle B, which is 25 degrees. Cross multiply, I get A times the sine of 25 degrees equals 15 times the sine of 48 degrees. To get A by itself, we divide both sides by the sine of 25 degrees. Okay, sine of 25 cancels sine of 25. This cancels, taking the sine of an angle cancels, but you can't cancel the word sine and say it's 48 over 25. Do not do that. Sine 25 is equal to sine 25, so dividing anything by itself is 1, but the sine of 48 does not equal sine 25, so you can't just cancel the sines here. But these cancel, and we get A equals. Now I'm going to put this in my calculator. I didn't know I closed that. Clear. Window, oops, mode. Make sure we're in degrees. And clear. And now I'm going to say 15 sine 48, close parentheses and hit enter. There's my numerator, divided by, close or open the parentheses, sine 25 degrees, close the parentheses twice, and hit enter. And I get 26.4. It's an approximation, so let's do that. It's approximately 26.4 degrees. Not degrees. My fault. It's not a degree. It's a length. Side A is approximately 26.4 units long. Okay. And then after I do that, I want to find C. So now I'm just going to move this over here, and we'll substitute in our givens there. So what is B? B is the side opposite. That's 15 over sine 25. So notice 15 sine 25 is right here. We're using it in both proportions. We don't know C, but we know the angle C, and that is 107. Cross multiply. C times the sine of 25 degrees equals 15 times the sine of 107 degrees. Divide by the sine of 25 degrees. Divide by the sine of 25 degrees. Sine of 25 cancel. I get C is approximately this. So in my calculator, let me clear it so I start over. Put the numerator in, 15 sine 107, enter, divided by parentheses, sine 25, close parentheses twice, enter, 33.9. So the measure of angle A, is 48 degrees. side A is 26.4, and side C is 33.9. So we found all of the missing components, and that is solving a triangle. Now try number 16 in your exercises. Okay, example 5, using the law of sines with angle, side, angle. Okay, so now we have an included angle, or I'm sorry, an included side and two angles. So a surveyor makes the measurement shown to determine the length of a bridge to be built across a small lake from North Picnic area, so from A, to the South Picnic area, B. He wants to build a bridge, which is side C. Find the length of the bridge. Okay, so that's the first thing you want to do. Just make sure you know what you're looking for, and you're looking for C. Let me pick a different color. Let's use that. That'll work. Okay, so we're looking for side C. Alrighty, so with respect to side C, we have angle C, and we have angle A, but we don't know angle B. So let's first start by doing the triangle sum theorem. So the measure of angle B plus the measure of angle A plus the measure of angle C equals 180 degrees. We don't know B, and that's why I put that angle first. The measure of angle A is 71 degrees, and the measure of angle C is 60 degrees. So you write a formula, you substitute your givens, you simplify and solve. The measure of angle B plus 1 plus 0 is 1, 7 plus 6 is 13, 131 degrees equals 180. Subtract 131 degrees, and we get the measure of angle B. So the measure of angle B equals 8 to 7, 10 minus 1 is 9, 7 minus 3 is 4, 1 minus 1 is 0. The measure of angle B is 49 degrees. Okay, so now we found B. So we know B and we know side B, that's our middle ratio. So I'm going to say, and we're trying to find the length of a bridge, that's a side. So put what you're trying to find in the numerator over the sine of the angle equals B over the sine of the angle equals side C over the sine of the opposite angle. And there it is. Substitute the givens. So I'm going to show you that since we know B, that's going to be 150 over sine 49. So that's why I put that in the middle. I know both. And that's going to equal, I don't know A, but I know angle A. So I say the sine of 71. And that's going to equal C, which we don't know, over the sine of 60 degrees. Okay, it says it didn't say to solve this triangle, so we don't have to do all of this. But what we do need to do is find what they're asking for. So pay close attention to what they're asking for. And it is find the length of the bridge, which was side C. So use what you know both of, and this is what we're trying to find is C. So I don't care about this at this moment. Okay, this does not matter to us in this problem. It did not say to solve the triangle. It just said find side C. So let's just focus on that. So you get C times sine of 49 when you cross multiply. You get 150, not degrees, 150 times the sine of 60. To get C by itself, you divide by the sine of 49 degrees on both sides. Sine of 49 cancels, sine of 49 cancels, and you get C is approximately this in your calculator. So open the calculator up, and I'm going to do, oh, it shut off, so I'll turn it on. Always check to make sure it's still in degrees, clear, and here we go. 150 times the sine of 60 is the numerator, divided by parentheses, sine 49. Close parentheses twice, enter 172.1. Okay, it didn't say what to round to, but we've been rounding to tenths. So I'll just put 172.1 meters. And how do I know it's meters? Because AC is drawn in meters, 150 meters. So my answer is the bridge will be 172.1 meters long. Okay, so now you should be able to do problem number 13 in your exercises. Okay, so now we're going to do the law of cosines. This usually gives students a little more trouble than the law of sines did. The law of sines is simple. It's opposite, it's side over opposite sine angle, or the sine of the angle over the opposite side, and all three ratios equal. In this case, it's a little bit more challenging to remember. It says you can use the law of cosines to solve triangles when two sides in the included angle are known, SAS, or when all three sides are known and no angles are. And let me explain why you can't use the law of sines when you don't know any angle measures, because you'd end up with this: A over sine of A equals B over sine of B equals C over sine of C. Let's just say I knew A was 4 and this is 6, for example. Well, if A is 4 and C is 6, okay, and I compare those two, then I'd say 4 over the sine of A equals 6 over the sine of C, and I cross multiply, I get 6 times the sine of A equals 4 times the sine of C. Well, unfortunately, we have two unknowns, and you can't solve a problem when you have that. So that's why we can't use the law of sines when we don't know any of the angle measures. But if we know three sides, we can use the law of cosines, or if we know one angle and the two sides that create it, or the angles included in those two sides, we can use the law of cosines. So SAS and SSS is cosines. Okay, so it says if triangle ABC has side lengths A, B, and C as shown, then the following rules are true. A squared, so this side squared equals this side squared plus this side squared minus 2 times those two sides times the cosine of the opposite angle. Okay, and that can get a little confusing, and then it just rotates for everything you're trying to find. If you're trying to find B, then it would be B squared equals A squared times C squared times 2 times A times C times the cosine of B. Okay, and actually it's really not that bad. Once you do a few of them, you do tend to remember them. So depending on what you're looking for, the side you don't know is the one you're going to put on the other side of the equal sign. So let's take a look at that in an example. All right, example 6 is using the law of cosines. So we have side angle side case. So here's a side, and here's an included angle. So it's right here, the two sides that form this angle. So that's what we're looking for first. What do we have? They told us here, use side angle side, but if I just gave you this diagram, you have to be able to identify what you have and what you need to use. So we're going to use the law of cosines, side angle side case. We're trying to find the measure of angle B. So the equation is going to be B squared equals. And then you just list the other two sides, A squared plus C squared, the other two. So B squared equals A squared plus C squared minus 2 times those two sides not squared times the cosine of the angle opposite that you know, which is cosine of B. Okay, so the formula is really not that bad once you do a few of these. So we're trying to find B squared, and we substitute our givens. A is opposite angle A, that's 11, plus C, which is opposite angle C, which is 14, minus 2 times 11 times 14 times the cosine of 34 degrees. So B squared equals 121 plus, okay, let me show you what I'm doing. 11 squared, 14 squared, 196 minus 2 times 11 times 14 cosine 34 degrees. Okay, so up until this point right here, I can simplify. But once I get to that minus sign, you have to do this multiplication and do it times the cosine of, I forgot the 3, 34. So I'm going to combine these two. So b squared equals 1 and 6 is 7. 2 and 9 is 11. Carry the 1. 317 minus, and I'll do this. 2 times 11 times 14 and simplify that to 308 cosine, forgot the O, 308 times the cosine of 34 degrees. Okay, so 317, multiply these, get that. Now be careful. Remember order of operations. PEMDAS says to parentheses first, there aren't any. Exponents, there aren't any. Multiply, so we have to do this first. So b squared is going to equal 317 minus, and then I go to my calculator and say 308 times the cosine of 34. So you have to do that multiplication first, and I get 255.34. So I'm going to write 255.3 because it says round the nearest tenth. And so b squared equals 317 minus my answer, which is 61.7. And then I take the square root of both sides. Okay, and that's going to give me b equals the square root. So I'm going to go square root, second answer. So I'm not rounding until the very end. 7.85 rounds to 7.9. Okay, so there is side B, 7.9. So 11, 7.9, and 14. So now let me just move all of this over to here. All right, so it says now here, it says solve the triangle. We're not done. So I found B. Okay, let me write that in there. B is 7.9. So I need to find angle A and angle C. So I do the law of sines to find these angles. So I want to find the sine of A or C. It doesn't matter. I'm going to do A. So I'm going to say the sine of A over side A equals sine B over B. And the reason I'm doing that is because B was given. Side B, we just found 7.9. Okay, and we substitute our givens. So we don't know the sine of A because we don't know A. So sine of A over side A, which is 11, equals the sine of 34 degrees over B, which is 7.9. So I'm going to cross multiply, and I'm going to get 7.9 times the sine of A equals 11 times the sine of 34. Divide by 7.9 to get sine of A by itself. And I get the sine of A equals, because these canceled, and I'll put this in my calculator, 11 sine 34, enter, divided by 7.9, enter. I get 0.7786. 0.7786. Almost done. We want to find A. So A equals, move the sign over to the other side, makes it an inverse, 0.7786. So angle A equals second sine 0.7786. Actually, let me do this. Just so I'm not rounding and I'm more accurate, I'm going to say second answer right here and hit enter. And I get 51.13 or 51.1 degrees. Okay, so there's angle A. Whew. And then finally, we have to do the triangle sum theorem to find B. I'll do that in blue right here. So B, triangle sum theorem, the measure of angle B plus the measure of angle A plus the measure of angle C equals 180 degrees. The measure of angle B is Oh, it's 34. 34 degrees plus the measure of angle A, 51.1 degrees, plus the measure of angle C equals 180 degrees. Add these, we get a 1 decimal. 4 plus 1 is 5. 3 plus 5 is 8. Plus the measure of angle C equals 180 degrees. Subtract 85.1 degrees, subtract 85.1 degrees. And I'm going to get this to cancel. And the measure of angle C equals that's going to be 10. This is going to be 7. This is going to be 9. I'm borrowing, by the way. So 10 minus 1 is 9. 9 minus 5, 4. 17 minus 8 is 9. The measure of angle C is 94.9 degrees. So then I take my highlighter and I say, okay, I had to solve this. I knew 3. I found side B. I found angle A. And I found angle C. Now I have solved this triangle. All 3 pieces that were missing are now found. Now try this on your own on example 20. Exercise 20. Okay, example 7, using the law of cosines with a side case. So here we have 3 sides and no angles. Okay, so what do we do here? Well, it doesn't matter. We're going to pick one and we're going to find one of the sides or one of the angles by the law of cosine. So I could find angle B, I can find angle A, or I could find angle C. The book I'm just looking says they did B, but I could do A, I could do any one of them, doesn't matter. Let's find B first because that's what the book said. So if we're going to find B, you start off with B squared equals A squared plus C squared minus 2AC times the cosine of the angle that's opposite the side you're looking for. Okay, so there's our formula. Substitute the givens. B is 27, so 27 squared equals A, which is across from A, 12. 12 squared plus C, 20 squared minus 2 times A times C times cosine B. Okay, so again, let me get my trusty calculator out. On, mode, second quit, 27 squared, enter. 729 equals 144 plus 400 minus 12 times 10 is 120, so 12 times 20 is going to be 240, times 2 is 480. That will be 480 cosine B. 729, add these, which would be 544 minus 480 cosine B. We're trying to get B by itself, so now let's move 544 over to their side. So minus 544 from both sides. 9 minus 4 is 5, 7, 6, 12 minus 4 is 8, 6 minus 5 is 1. 185 equals negative 480 cosine B. Watch your signs here. Divide by negative 480, not 440, 480. Divide by negative 480. These cancel, and I'm going to get cosine B equals 185 divided by negative 480. Enter, and I get a negative 0.385. To get B, we move the cosine to the other side, and it's cosine inverse of negative 0.3854. So B is approximately, and I'd go second cosine, second answer to put this in without rounding, and I get 112.7. Nearest tenth, B is 112.7 degrees. It's an angle. So there we go. B is 112.7 degrees. So now we know B. Now we need to find A. So now that we found one angle, we now know an angle and a side, we can now use the law of sines. So we're now trying to find angles. So the sine of A over A equals the sine of B over B. And then I'm, oops, lowercase b, it's a side. Okay, so that's one of them. And then I'm also going to do the sine of B over B equals the sine of C over C. Now I'm going to substitute my givens. The sine of A over A, which is 12, equals the sine of B, which is B is sine of 112.7 degrees over side B, which is 27. And I'm just going to keep substituting these in. So now I'm going to do the sine of 112.7 degrees over B, which is 27, equals the sine of C over side C, which is 20. All right, so there's all of our substitutions. Now we're going to cross multiply. And so it's going to be 27 times the sine of A equals 12 times the sine of 112.7 degrees. Divide by 27, divide by 27. These cancel. The sine of A equals 12. Sine 112.7. Okay, sine of 112.7, enter, divided by 27. And I got 0.4100. And that's an approximation. And now I'm going to find A by taking the sine inverse of that 0.4100. So A is going to be approximately second, sine, second, answer, enter, 24.2. That is a degree. Now, finally, we're going to find angle C. Same way. So it's going to be 27 times the sine of C equals 20 times the sine of 112.7 degrees. Divide by 27, divide by 27. These cancel. I get the sine of C equals 20 sine 112.7, close the parentheses, enter, divided by 27. Enter. And I get 0.6834. That's an approximation. Okay, and now I want to find C. So I move the sine over to the other side. And to do that, we have to take its inverse, and we get 0.6834. So I'm going to take second sine inverse of my answer, which was 0.6834, and I get 43.1. So there's my three angles. 112.7, 24.2, 43.1. Now, if I were to add all of those up, I should get 180 degrees. The other way, instead of doing this in red over here, I could have done the triangle sum theorem after doing what I did in purple. Either way, you get the third angle. Okay, so now you should be able to do problem number 24 and 22, 22, and 24 in your exercises. Okay, example 8, count them, 8. Wow. All right, solving a real life problem. An organism's step angle is a measure of walking efficiency. The closer the step angle is to 180 degrees, the more efficiently the organism walked. The diagram shows a set of footprints for a dinosaur Find the step angle B. So here is B right here. We don't know the angle, but notice what we do know. A side, a side, a side. Okay, so when it's S, 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 we have to use the law of cosines because we don't have any angle measures. And I want to find B. So I'm going to set it up. You can either say a squared equals b squared equals or c squared equals, but when you're trying to find b, you need to start with the b squared equals, leaving the other two as a squared plus c squared. Okay, and then it's going to be minus 2, this side and this side, which is AC repeated, times the cosine of the angle you're looking for. So b squared is 316 squared equals a squared, which is opposite a, which is 155 squared, plus c squared. Here's c, so opposite c is 197. 197 squared minus 2 times a times c. That's a 9. That's a 9. 197 times cosine b. So notice what we have here: a number, a number, a number, a number, a number, a number, an unknown. We're trying to find cosine of b. So this is the only component we don't know. So I'll just change its color to black here. We're looking for cos b. Okay, so these are some pretty big numbers. So let me get my calculator out, turn it on, clear, and here we go. 316 squared, enter, 99856. Okay, I wanted to be red here, so let's choose red, and let's choose this. Let's change that to red. Sorry about that. Choose this. Let's change it to red and continue with red. Okay, so 99,856 equals 155 squared, which is 24,025, plus 197 squared, which is 38,809, minus, and then I'm just going to multiply all three of these together. 2 times 155 times 197. And hit enter. 61,070 times the cosine of b. Okay, so I'm going to combine these here. Do not combine all three. Remember our order of operations. If you do that, you'll get the wrong answer. PEMDAS says to combine like terms. We have to do parentheses, then exponent, then multiply, then divide. So this is multiplication over here, and this is addition. So we're trying to get this 61,070 cosine b by itself first. So this is going to become 99,856 equals, and it's 24,025 plus 38,809. And I get 62,834 minus 61,070 cosine b. Okay, and so this is multiplication here. So I can't, you have to do multiplication first, then add, subtract. That's why I'm not combining these. I'm actually trying to get everything away from cosine b by doing inverses. So now I need to switch colors. Now I need to subtract 62,834 from both sides. Okay, so these are going to cancel. 6 minus 4 is 2. 5 minus 3 is 2. 8 minus 8 is 0. 9 minus 2 is 7. 9 minus 6 is 3. So we're down to 37,022 equals negative 61,070 times cosine of b. Okay, now I need to get cos B by itself. It's being multiplied. Now I'm going to divide by negative 61,070, both sides. Negative 61,070. And these are going to cancel. And I'm going to get cosine B equals, and I'm going to take that 37,022 divided by a negative 61,070, and I get negative 6062, negative 0.6062, and that's rounded, so I should have an approximation symbol here. And then to solve for B, you need to move cosine to the other side. So I'll just write, I'm trying to solve for angle B. So I'm going to get B equals, no, I'm not. Yeah, I am. Just leave it like that for now. B equals the cosine inverse of negative 0.6062. And I put that in my calculator, second cosine inverse, and my answer is right up here, and I don't want to round, so I hit second answer to bring that answer back down and without rounding, and I get 127.3. It didn't say what to round to, so let's just round to the 10th. So that's going to be, it's going to come out to B. B is approximately 127 point, didn't write the 7, 127.3 degrees. Okay, so they asked to find the step angle. So the step angle was 127.3 degrees. All right, and so that's how you solve a real life problem. Now try exercise 33. Okay, so that brings us to the end of chapter 9.7 and the end of chapter 9 in its entirety. Please do these exercises. Thanks for watching and have a great day.